Have you ever popped open your home's electrical panel or maybe walked past a massive industrial switchboard and just felt completely overwhelmed by those rows of identical looking switches? Yeah, you're definitely not alone. Well, today we're going to decode that whole setup. We're breaking down miniature circuit breakers, or MCBs, and really digging into the hardware that's keeping our homes and our electronics safe.
To do this, we're leaning on a really fantastic breakdown from electrician Buzz. They lay out the crucial operating differences between key circuit breakers and isolators. And what I really love is how they completely strip away the heavy jargon. It's all about what these devices actually do when the power starts flowing.
Okay, let's dive into this, because right off the bat, there's a staggering statistic. According to our source, 90% of people have absolutely no idea what the difference is between these breakers. Most folks just see a switch and figure, hey, they all do the exact same thing. But using the wrong breaker for the wrong device, it's not just inefficient, it totally defeats the entire purpose of having a safety system in the first place. So here is our roadmap for this explainer. We're covering the C-type for medium inrush current, the D-type for high starting current, the B-type for low inrush current, and finally, the isolator exception. The main thing we're tracking across all of these is inrush current. Basically, that initial surge of power a device pulls the exact millisecond you turn it on.
All right, Section 1. The C-type, medium inrush current. So what exactly is a C-type MCB? Simply put, it's a circuit breaker designed specifically for devices that produce a medium inrush current. Think of it like a bouncer at a club that's just a little bit forgiving. It allows for a moderate temporary spike in electrical demand without instantly tripping and killing your power. It lets standard devices power up, but it's strict enough to cut the power if that surge lasts a little too long and becomes a hazard.
To put that into a real-world perspective, you actually use these all the time. Common applications are your standard bulbs, your ceiling fans, and just ordinary, everyday home circuits. When you flip the switch for a ceiling fan, the motor needs a little extra juice to get those heavy blades spinning from a dead stop. The C-type breaker is smart enough to recognize that medium surge as totally normal operation, so it lets it happen. This is the hardware you're interacting with the most at home.
Now, what's really interesting here is the nuance in how these C-type setups can actually be wired. A basic setup might just disconnect the phase wire, which is the one actively bringing the current in. But a more advanced setup disconnects both the phase and the neutral wire, the return path, at the exact same time. By severing the circuit entirely, it gives you a really secure extra layer of protection.
Moving on to number 2, the D-type for high starting current.
Now we're stepping up the power scale to the absolute heavy lifter. The D-type MCB is incredibly heavy-duty. It's used for devices that draw a massive amount of starting current. To put this into perspective, if you tried to plug a D-type appliance into the C-type residential breaker we just talked about, that huge initial power surge would instantly trip the breaker and shut your whole house down. The D-type is engineered specifically to absorb that huge initial jolt, making it absolutely essential for industrial applications.
Because of that, you're definitely not going to find these in your average living room. We're talking heavy electric motors, massive industrial air compressors, and large-scale factory machines. Think about the sheer mechanical force it takes to jumpstart an industrial compressor. I mean, it needs a huge, immediate gulp of electricity. The D-type breaker allows that extreme, split-second surge to pass through safely without plunging the whole factory floor into darkness.
All right, Section 3, the B-type, low inrush current.
Let's shift gears and go all the way down the power scale to the most sensitive category on our list. The B-type MCB is built specifically for circuits that experience very low inrush current. Because the devices hooked up to this don't need a massive shock of power to wake up, the breaker itself doesn't need to be forgiving at all. It is highly sensitive. If there's even a tiny, unexpected spike in electricity, the B-type snaps into action and immediately cuts the power. It is your absolute go-to safeguard for highly sensitive electrical pathways. The perfect real-world examples for B-types are dedicated lighting circuits, especially modern LED lights and similar low-draw bulbs. LEDs are so incredibly energy efficient, right? They simply don't need a massive jolt to illuminate. And because their starting current is just so incredibly low, a highly sensitive B-type breaker is the absolute perfect match to protect them. And finally, Section 4, the isolator exception. So we have to talk about the exception to the rule here, stepping away from standard breakers completely to look at the isolator.
Visually, an isolator might look exactly like the standard B, C, or D type breakers sitting right next to it on your panel. It's got a switch, it's in the exact same plastic housing, but functionally, it is a completely different tool. And mistaking it for a true circuit breaker is a really dangerous fundamental error. So the crucial point is this. On one hand, an isolator securely isolates the power supply to perform basic switching, literally just turning a circuit on and off. But it has one critical limitation. It does not have the facility to break an electric arc. When a real circuit breaker trips during a fault, it safely snuffs out the literal arc of electricity trying to jump the gap. The isolator absolutely cannot do that. That's exactly why it can never be used as an active protective safeguard. It is purely for isolation, not active fault protection.
And this brilliantly illustrates our whole breakdown today. We've got the highly sensitive B-type for low-draw LEDs, the versatile C-type for everyday home devices like your ceiling fans, the heavy-duty D-type for massive industrial compressors, and sitting in its very own distinct lane, the isolator, which is strictly used for switching, not protection. Seeing it laid out like this really cements the whole system into memory, doesn't it?
Remember how we started by pointing out that 90% of people don't know the difference between these critical electrical components? Well, congratulations, you are officially in the top 10% who actually do. But I want to leave you with the exact same provocative question our source text asks. Did you know this? Seriously, think about the electrical panel in your own home right now. Which of these are actually protecting your devices? Keep observing, keep asking questions, and I'll catch you in the next explainer.